welcome to lesson 5, property of exponents. In this lesson, this is an actual standard that you can use in regular 8th grade math, general 8th grade math, as well as high school Algebra I. We're going to look at the different structures of expressions that have exponent rules, and you're going to see how I use my reference chart to help me simplify the problem. Now, if this was a general 8th grade class, we spent several days on this, so you can go back and review those videos. Or if this is just your first time doing exponent rules, we can use this chart to really help us identify what to do. And then we're going to use that information and property to accurately and consistently recognize what rule and then simplify the expression. Okay, that's going to be our goal. So let's take a look. These are the different properties we're going to look at. There's 6 of them here. We have the zero exponent property. In other words, if I have a number, any number to the 0 power, it is just equal to 0. And I have a great video on our Math Mini Lessons YouTube page that explains why that is. So anything to the 0 power. So even if I had 58 to the 0 power, it's always going to be equal to 1. Anything to the 0 power is just 1. Then we have negative exponents. So if you see any negative sign, the negative exponent rule, we're going to turn it into a fraction. So if I have 5 to the negative 8, all we're going to do is change that to 1 over 5 to the 8. That's the negative exponent rule. We have the product of powers rule. Looking over here, product of powers, and all that says, if notice you have the same base, then all you're doing is you're taking whatever these two numbers are and adding them together. So if I have 2 to the 3rd times 2 to the 4th, it's still a 2, and all you're going to do is add the 3 and the 4 together to get 7. Okay, and the opposite of that is the quotient of powers rule. So again, if I have 2 to the 3rd divided by 2 to the 4th, you're going to end up with a 2, but this time you're going to subtract those numbers. So 3 minus 4 is negative 1, so you're just going to subtract. And then that'll give us a negative. So don't worry about that one for right now. Then we're going to look at the power of products rule. Now these next two, they look very, very similar. So I wanted to make sure you know the difference. The big difference here, the power of product, you have two numbers inside of parentheses and you have an exponent on the outside. So all you're going to do is you're going to split those two numbers up with the same exponent. So what does that look like? Let's say you had 3 times 4 to the 3rd power. You're going to do 3 to the 3rd power times 4 to the 3rd power. And then you're going to simplify out and solve that answer. Versus the power of products rule. So let's say you have 3 to the 4th, and then here's another parentheses, and you have another number on the outside. In this case, what this says is a to the nm, you're just going to multiply these together. So 4 times 3 gives us 12. Okay, so this is just really high level. Again, I slowed this down a lot in the 8th grade general, but for now, since it's high school and we're a little bit more accelerated, we're just going to use these integers to work through, and I will link at the end of this video or inside the comments the link to break down all of these different rules if you want to actually know a little bit more about how they work. Okay. All right, so again, I'm going to use my reference chart to help me recognize which one I have, what structure I have. So let's start with the first one. What do you see? What do you notice? I notice I have two numbers in a parenthesis. So automatically I am thinking of, I can recognize it here, the power of product rule. So I'm going to put that in there. Power of product. I call it a rule. I know I have it as a property here. So again, just so we can see, that would be two numbers, a times b, and whatever the number is on the top would be whatever the first term is to the nth power times whatever the second term is to the nth power. So let's try that out here. In this case, our a, we have 2 times 11. So we know that's going to be 2 to the second power. I'm going to change the color. So 2 to the second power times 11 to the second power. Now, if I was going to keep on going, I would actually figure this out. 2 squared is 4, 11 squared is 121, and I'd multiply them together. But in this one, I'm saying do not evaluate. I just want to be able to recognize what this is and just model that out. So let's look at the second one. And again, what do you see? What do you notice? I have another one with parentheses where I have something on the inside and something on the outside. So that tells us that anytime it's parentheses, it's going to be one of these two, the power of product or power of power. In this case, this is a power of power. They stack up on each other. So this is power of power. And again, this is where it looks like a to the m, then to the m power. I would just take those two exponents and multiply them together. So in this case, it would be 2, and then I would multiply the 2 and the 3 together to get 6, 2 to the 6th power. And I would evaluate that, but I'm not going to do that here. Okay. All right, now look at the last one. What do you see? What do you notice? I know it's a fraction bar. It has to do with division or quotient. So automatically, I'm looking at the quotient property rules. Quotient of powers. Okay. And what does that rule show me? I have a to the m over a to the n. And again, the a stays. I would subtract those two. And notice I'm subtracting the top and then the bottom. So in this case, I have 7. And I would do 9 minus 11, which would be -2. And then what would happen here? I would have a negative exponent. And for that one, again, it means I would turn to a fraction 1 over 7 to the second power. Okay, and that's all we're doing for today. Same thing, this is all really new. So use this table, use the reference, and think first, what do you see, what do you notice about the expression? That will help lead you to which is the actual power rule, which is the rule you want. And then you can use that model to help you solve it out. Okay, that's what we're going to be doing for today. So that's it. Make sure you're using your checkpoint to ask for very specific feedback. So if there's a step you're stuck on, say it, name it. That's the place to do it so that you get appropriate feedback, whether it's, hey, I just want to practice out and know how I'm doing. I need feedback there, or I'm really stuck and I need someone to break this down further. I need feedback there. Ask for the support that you actually need so that you get it before you get to the exit ticket. That's it for today. I will see you in the next lesson. And again, if you want to see these rules in action, I will link them in the comments. See you in the next lesson. Be well.